video is showing you how to deal with stem and leaf diagrams and box plots on the S1 course. If you haven't already printed off the document that goes with this, that has these examples in it, then you need to do that now. It's on Moodle in the same chapter of the book. The objectives then, you want to understand what the data in the stem and leaf diagram is telling you, so actually be able to read the diagram and understand what the stem is, what the leaf is, what the numbers in the brackets are, what the key means. Use the diagram to locate medians and quartiles, so you've already had a lesson calculating those, and this is just doing the same thing but using the diagram. You want to be able to locate outliers using a given formula, and where relevant, that is, and represent them using a box plot. And finally, you want to compare box plots for different data sets, including mentioning skew. Okay? So, the example, I'll give you a chance to read that, so if you need to read it, pause the video now. So this is your actual data, and it's been put into the stem and leaf diagram already. So what you've got here, first of all, is the key. So the key here, it's got 18 in the middle, is relating to this 18 just here, and that's the stem. And if we look at the values in the hundreds and the tens columns, that's telling us that the 1 is the hundreds value and that's the tens value. That means that the leaves, so on this side and this side, for instance for ASIF, 184 means 184 for ASIF. Okay, 184, 184, 204, 204. On this side, we've got Keith going in the opposite direction. So, for instance, 180, 180, 182, 182. Okay. What I've done over here already, we've got the numbers of pieces of data that are on each row. I've calculated the cumulative values. So, for instance, here we've got 9 values, but if you get to this value, it's 9 plus 11, which is 20. You've done a similar thing for cumulative frequency diagrams at GCSE. Just to check you understand what that means, we're going to do the same thing, but we are going to do it, sorry, can't use the system, we're going to do it on this side, so we've got 4 bits of data there, 5 there, 4 plus 5 is 9, that means that's the 9th value. It's only a coincidence that that says 9 there. Okay, then 9 plus 6 is 15. Keep going, 15 plus 7 is 22, 22 plus 7, so at this stage here, ASIF hasn't got any more data to add on, so it's still 42 bits of data at this point. So, that means for ASIF, n is 42, for Keith, n equals 43. So you should remember how to calculate medians and quartiles from your previous lesson, but we'll go through the median on this side and the quartiles on this side. Neither of the two values that you've got for n are multiples of 4, which means for the quartiles, whenever you divide by 4, you are not going to get a whole number value. So it's always the same system for the quartiles. The median, if you were calculating the median for ASIF, then you would divide that by 2 and get 21, which means you get a whole number value, and it's a slightly different method to get his median. I'd strongly recommend that once we've gone through these two methods to get A, B and C, you check that you remember how to calculate the other values that are given by running through that yourself. If you don't get the same values that it says on the table, go into the next lesson and ask your teacher why, or even better, research it to make sure you understand why. Okay, so we need the median, and to get the median, which is Q2, we need to know what 43 divided by 2 is. 43 divided by 2, 42 divided by 2 would be 21, so it must be 21.5. Strongly recommend you do that using a calculator. So we get a decimal value, we always round up so that it's the next value that we need to take, so the 22nd value. And And the 22nd value, because we've done the cumulative frequencies, the 20th value was there, 21st, 22nd, 202. Okay, so I'm going to put that in the table. If you were doing it for the exam, B equals 202. Make it nice and clear. Okay, so for ASIF we need the quartiles. So for the lower quartile, Q1, we calculate a quarter of the amount of data. A quarter of 42 is 10.5. So we're after the 11th value. Again, you get a decimal, you round up. If this was 11.25, or rather 10.25, you would round it up to 11 as well. 11th value, 9th value is 199, 10th, 11th, 202. Not intentional. Okay, so we've got A and B. C now, what would be worthwhile for you is to pause the video, make sure you can get C yourself, and then run the video to check that you've got it correct. And what you should have done is found that 3/4 of 42 is 31.5. You want the 32nd value, and the 32nd value, 29th is there, 30, 31, 32, 233. Okay, so C is 233. You would have more room in the exam to write out your method and your answers, and you need to make them really, really clear. Okay, so the next question. Next question is asking us to calculate outliers for Keith's data. So the idea with an outlier is it's a bit of data that doesn't seem to fit in to the rest of the data because it's outside the range. So, not outside the range of the data because that would be ridiculous because it's part of the data set, but it doesn't fit in with the data because it's either too big or too small. And the method for calculating it is if it's below this calculation, and these are just numbers, Q1 for Keith, Q1 is 191, Q3 is 221, Q1 again 191. So if it's below that value, it's considered an outlier and it shouldn't be included in the data set. You should definitely be suspicious of it. And then if it's above this value, so Q3, if it's above that, then it's also considered an outlier. So if we calculate this here, then we get 191 minus 1.5 times 30, and this is 221 plus 1.5 times 30. That's not a coincidence. This here, Q3 minus Q1, is actually the interquartile range. So it's not supposed to look like a dot. And so we work what that out is, and 191 minus 45 gives you 146. And 221 plus 45 is 266. Again, strongly advise you don't just base it on mental calculations. In an exam, we can get flustered, so it's worth checking on your calculator. So if we go back to the 7-leaf diagram, we haven't got any values that are below 146 in our data. In fact, they're very safely within that range, much, much higher than 146. However, we have got one value that's above 266, which means that 269 is an outlier. Okay, so that's answered that question. We're going to go on to the next one. So now it's a case of drawing a box plot to represent Keith's data, and it is very sensible as well for us to have our outlier. Don't know why that looks like a Q. Outlier. which was 269. So the lowest value for Keith was 180. Highest. The highest value now is the highest value in his data that doesn't include the outlier. So his highest value now is 263. Okay? So the values you need to include in the box plot, just like you did at GCSE, are the lowest value, lower quartile, median, upper quartile, highest value. Okay? So you will still have a box plot that will look something like that. And you'll have, that will be the number on the scale 191, 202. That's not right, is it? 180 is the lowest value. 191 is your lower quartile. 202 is your median. 221 upper quartile. And then your highest value is now 263. What do we do with the outlier? We still need to show there is an outlier. So on the scale, we find where the outlier is, and we put a cross. Okay. So we need to do that now to scale, and using a ruler and a pencil, which I don't have to hand. So, if we write 180 here, 200, you can try out different scales. It makes sense to use the decimal system and make sure that the increments that you use going up in tens are sensible ones. That makes sense. We need to label the axis. So it was miles. You can put miles travelled, at least we put a label there. And then the lowest value, 180, that's going to be the bottom whisker. The highest whisker is going to be 263. So 262 is there, so 263 goes here. Again, using a ruler. 191, so 190 is there, 191 is going to be here. 202. 221. There's our box. There are our whiskers. And then we put a cross at the 269. So 269 there. Okay. That's what that looks like. Final task is to comment on the skewness of the two distributions. So, skew is thinking about how the data is spread. So is it kind of bunched up at one end, bunched up at the other end? Does it look evenly spread out? So we think about a box plot. Each of the sections is representing 25% of the data. 25% here, 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 and here. So that's very spread out, that 25%. And compared to the data that's below the median, that is is more spread out as well, above the median. When it looks like this, we have what's called positive skew. Which means that Q2 minus Q1 is less than Q3 minus Q2. So it makes sense to say then, if you have got negative skew, your inequality turns around the other way, and the data above the median, it's not that clear on this particular diagram, but that is more scrunched up. Okay, and the data below the median is a bit more spread out. So then we would have negative skew, and Q2 minus Q1 is greater than Q3 minus Q2. Symmetrical, hopefully you can work out why that's symmetrical. It should be evenly spread out about the median, and so symmetry or symmetrical would be Q2 minus Q1 equals Q3 minus Q2. So if we look at Keith and AJ, we need to give evidence, just like you should have to do in any situation. You have to give evidence for a decision you come to. So if you're going to say that Keith's data is symmetrical, you need to give a reason. If we just look at the box plot, we can see it's positive skew, but that's not enough to get you the marks. You need to give that back up with the with this evidence as well. So for Keith, Q2 minus Q1 and Q3 minus Q2. Q2 minus Q1 for Keith is 11. Q3 minus Q2 is 19. We can see that 11 is less than 19, so that is positive skew. For AJ, as if, that was my previous question, as if we work out Q2 minus Q1 and Q3 minus Q2, then we work out Q2 minus Q1 is 16 and Q3 minus Q2 is 15. Now, 16 is bigger than 15, but not by much. So you're probably better off saying a slight negative skew. You might, depending on the size of the data set, you might even want to say it's almost symmetrical. You would get away with that. Okay, thank you very much. Now what you need to do is try the questions that relate to this that are in the same Moodle chapter. Okay, Moodle book chapter.